Hello and welcome back to Let's Make a Game in C++. This is going to be episode 6, and in this episode we'll cover two things. First is going to be movement again, because this time we're going to do the movement of the ball that's going to bounce around the screen and of the pad. And the second part is the bouncing of the pad, because we have to do collision checking. So we're going to check for collision between the ball and the pad. So everyone should start up their text editor on Linux, and Windows users should start up their IDE, Code Blocks, Visual Studio, whatever you are using. I'm just going to do Emacs. Some general info. Thanks for all the positive feedbacks, subscriptions, comments. It really helps to boost the morale, so I know that I'm doing it right and that you people like it, and I'm going to make more in the future, especially next week because we have holidays. And yeah, if you like them, if you like the videos, subscribe, like it, whatever. It really helps me making more of them. So let's get to the coding. This is our code from the last episode. I removed all the code that was commented because we do not need it. It only makes the file bigger and it looks ugly if you have unneeded code in there that is commented out. So let's run the game, and as you can see, we have from the last time we have our pad in the bottom corner, the bottom part, and you can move left and right till you hit the edge of the screen. So let's get right into programming the ball. And for the ball, we're going to use actually almost the same variables as for the pad. So this is the ball variables. And as you might think of, we're going to need an x variable and a y variable and a width and a height. So let's get to it. Float ball x is going to be the x variable, let's say 50. Float ball y is going to be the y variable, is going to be 50 at the start. And we're going to use one variable for width and the height because the ball is going to be the same width and height. And let's say like 30 pixels wide and high. The ball is going to be a rectangle, not a circle, but we won't bother with circles for now. It kinda looks maybe a little old, but it works for us. And because we are not going to control the ball, we aren't going to use Boolean values for controlling which button is pressed. And we also won't have to do any kind of programming in the events part, because events are tied to key presses and we do not move the ball with keys. The ball moves itself. And if we want something to move itself, we need to store the velocity at which it is moving. So we need an x and y velocity. And we're going to apply that velocity every frame to the ball's x and y position. So let's make two variables, each one for each axis. So we're going to do velocity x for the x velocity and set it to 0.2, and y velocity, and it's going to be 0.2. So that means that every frame, at least at the start, we're going to add 0.2 to x position and 0.2 to y position. That basically means that the ball is going to be moving right down, so to the bottom right corner at the start. And that's basically all the variables we need for the ball. Now let's render the ball, because that's one of the easiest parts. Here we have the begin and end of drawing for the pad, and we can basically simply start drawing the ball. We don't have to set up the matrix again or ortho, but we do want to change the color. So let's change the color. GL color for UB, and let's say it's going to be red. So 255 for red, 0 for green, 0 for blue, and 255 for alpha. So that's red color. And we can basically start drawing. GL begin, GL quads, it's going to be a rectangle, and GL end at the end. And in between we have to specify the 4 corners of the ball. And we basically already know how to do that. 4 points, GL vertex to F, and the first one is ball X and ball Y, the top left corner. Next one is GL vertex is ball X plus ball width height, so the width. So that is the upper right corner, and the Y position stays the same. Next is the bottom right corner, GL vertex to F, ball X plus ball width height. I'm going to say width height because it's the same variable. And the Y position is ball Y plus ball width height. So that's the bottom right corner. And the last one, GL vertex, ball X, so the left side of the ball, and ball Y plus ball width height is the bottom part of the ball, so bottom left corner. And we already have the ball drawn. Set the color, begin rendering, end rendering, and the 4 corners of the ball. So let's compile this. Compile. We need SDL GL. Oh, I forgot to add LGL. So that compiled successfully. Let me just put this down so I know if to compile, and we can run the game again. And as you can see, we have our pad and the ball up here. So that's 50 pixels to the right and 50 pixels down from the upper left corner of the screen. And its width is 30 pixels. But it does not move. And why not? Because we haven't set any logic. So let's do the logic part. This is the logic part. This is for the pad. And let's do the logic part for the ball. And basically, this is very simple. We just have to add the velocity to the position. So ball X is plus equal velocity X, and ball Y is plus equal velocity Y. And that's everything for moving the ball, because we have our velocity set 0.2 and we add that to the X position every frame, and we do the same for the Y position. So let's compile that and run, and the ball simply moves to the bottom right. But as you can see, it goes through the pad and through the windows and out of the screen, and we do not want it. We want to bounce off the window, so the borders of the window. And we have to do something similar to what we did up here for the pad. So pad, this is for left edge of the screen and this for the right edge of the screen. And we have to do the same for the ball, only we have to add for up and down edge of the screen. So if ball X is less than 0, then we have to change the X velocity it's going. And we simply negate the velocity. So velocity X is equal to minus velocity X. So at whatever velocity it was, it will simply just turn around and go the other way by negating the velocity. Now this is the left edge of the screen. Now let's do the right edge of the screen. Let's do an else if, so we optimize a little. If ball X plus its width, so the right edge of the ball, is more than 600, which is the width of the screen, then we also negate the ball X velocity. We're negating the X velocity because we're checking for the left and right edge of the screen, which is basically the X axis. Now we have to check the Y axis. So if ball Y is less than 0, we negate the y velocity. And for the bottom part of the screen, if ball y position plus ball with height, so that's the bottom part of the ball, is more than the screen is 400 pixels. So that means if it touches with the lower part of the ball touches the edge of the bottom of the window, then we negate the velocity of y. And that's basically it. This is the movement, and this is for checking if we hit edge of the screen. Compile and run. And as you can see, it cleanly, slowly bounces around the screen. If it hits the upper border, it negates the y velocity, so it goes down. And if left, now currently the x velocity is positive. Now it's negative, because positive goes right and negative goes to the left. So when we hit the edge, we simply negate it. But as you can see, it goes through the path. That's because we haven't set any collision detection. And so we come to the second part of the video, where we're going to check for collisions. And first I'm going to do some simple collision detection explaining using GIMP. I don't have a touch pad, so this might get a little ugly, but I think you'll understand what I'm drawing. So for checking the collision, we have to check 4 different states between 2 rectangles. So let's say this is rectangle A, and rectangle B is going to be somewhere else. And we have to check 4 states. The first one, if rectangle B is over rectangle A. If that's true, then there's no way that there can be a collision between those two. And we can simply say that there's no collision. The second state is if rectangle B is more to the right than rectangle A. If that's true, then there's no collision again. And the third state is under it. Again, if that's true, there's no collision. And the fourth state is if rectangle B is more to the left than rectangle A. And if that's true, then there's no collision. And if it happens that none of that states is true, then there's certainly a collision between those 2 rectangles. Because if the B rectangle is not over, under, more to the left, more to the right, then rectangle B, then it simply must be somewhere in rectangle A. And that means that there is a collision. Now, how do we check for collision? Well, we simply have to compare the nearest 2 edges of the rectangles. So for this state, we have to check this edge of the rectangle and this. So this is basically, this rectangle's y plus height, and this is A's y. And if this is less than this, then there's no collision, because this is then over the upper edge of a rectangle. And we have to simply do those checking for each of the 4 states. So let's get back to the code. And I wrote last time in the video info that you should take a look at functions, because we really need a function for checking collision, or else it's really ugly. So we're going to write a function now. We're going to write it outside the main of the program, so over it, just after the include sentences. So the function is going to be a bool type, because it's going to return true if there is a collision and false if there is no collision. We're going to name it check collision. And we have to put 8 parameters into the functions. A parameter is something that you give the function when you start it, so it has some variables, data, or something to work with. And the 4 parameters that are the x, y, width and height of each rectangle. So we're going the first rectangle. So float ax is going to be the x position of the first rectangle. Float ay is the y position. Float a width is the width, and float a height is the height of the first rectangle. Now let's get to the second rectangle. Float bx, float by, float b width, and float b height. So we have 8 parameters, 8 variables, 4 for each rectangle. Pretty straightforward. We could use structures to make it simple, but because I didn't say that we're going to use structures, so I won't use them. But please make sure that you take a look at structures and arrays for the next episode, because we're going to be adding blocks we're going to break, and I'm not going to do that without structures and arrays. So please take just a little look at structures and arrays, and maybe a little more into functions if you do not understand this. So let's get to collision checks. Now we have to check the 4 states. Let's start off with the first one. If rectangle A is over rectangle B, if AY plus A height is less than BY, then we return false, because if that is true, then rectangle A is over rectangle B and there is no collision, so return false. The second state, we're going to check if rectangle A, so A dot Y is more means lower, because Y axis goes from up to down, is more than BY plus B height. And if that's true, we return false. Next is the third state. A is more to the left than B. So AX plus A width is less than BX. Return false. And the last checking is if it's more to the right. So if AX is more than BX plus B width, that's true, return false. And if none of those is true, if none of those conditions is true and the function did not return false, then we return true, because that means that there is a collision. None of these 4 states is true, so there has to be a collision between those 2 rectangles. If you do not clearly understand this collision checking, then go to LazyFoo site. He has a very good tutorials about everything game development based, and you should check out collision checking. He has a better description of it, and you'll probably understand it a little more there than you do here. So this is the collision checking function, and now we have to simply use it in the logic part of the game. After we move the ball and change the velocity depending if we hit the wall, we're going to check for collision. So if check collision, and now I had to give it the parameters of the ball and the pad. So let's start off with the ball. So ball X, ball Y, ball width height, and ball width height, because they're same, so one is width and one is height. Now we have to put in the pads position, my X, my Y, width and height. And if that is true, so that means if there is a collision, we're going to change the Y velocity of the ball. So velocity Y is equal to minus velocity Y. We simply the ball is going down, so the Y velocity is going to be positive. It's going to hit the ball, the pad, and we're going to change the velocity, so it's going to bounce off and go to the upper border of the screen. Let's compile this. We have a error. Sorry for that. Compile and run. And the ball bounces off the pad. and of the borders. There is one little problem in this collision checking, because if we hit the ball with the left border of, as you can see here, the left border of the pad is going to still bounce, and that's not really what we want. But we're not going to check here if the ball is coming directly from the top. As you can see, it works. And let's make it a little more fun. We're going to do that if the ball hits the bottom edge of the screen, we're going to exit the game. So this is the condition for the bottom edge of the screen. And let's say is running to false. And what that's going to do, it's going to close the main loop and exit the game. So as you can see, we bounce off the ball, and like we now miss it, and the game closes. We basically lost the game because the ball hit the bottom edge of the screen. And that is for today's episode. Quite a bit longer than last time. I hope I didn't complicate too much, and I hope you like it. Next episode should be next week, because we have holidays. And well, that's all. If you like it, subscribe, and keep making sure that you check out Lazy Foo site, more info there, and thanks for watching.